Spring is there here. There is pulley. This is the pulley. 2M. This is 4M. M and 4M. So here, what is it? What is the elongation produced in the spring? The spring will produce an elongation. Elongation produced in the spring. So just already I told you that the spring is replaced by string. And you see, this is the string, and here there is a pulley. This is mass 2M. For M like this, 2M and 4M. So here under equilibrium, this is, what is it? 4mg is down, and there is a tension, and here this is 2mg is down, and there is a tension. On the pulley, there is a force is acting, tension is acting like this and this. So that the force acting on the pulley is 2T. Force acting on the pulley is nothing but FSP is equal to 2T. The spring force is 2T. Right? Spring force is 2T. And first, you find that acceleration of the system. Acceleration of the system is net pulling force by total mass. Net pulling force by total mass. So net pulling force by total mass, net pulling force is 4 mg minus 2 mg by 2m plus 4m. This is 2 mg by 6m. It is g by 3. It is the net acceleration of the system. Acceleration of the system. And find the tension here. Free body diagram for anyone free body diagram. So suppose if it is taken 4m free body diagram, 4m. So this is the tension, and it is 4 mg, and this block is coming down with an acceleration gain, and it is going up with an acceleration. So it is coming down with an acceleration, coming down with an acceleration, so that 4ma and Fr is equal to 4mg minus tension. So 4mg minus tension, 4ma is equal to 4mg minus tension. So this is 4ma. A is equal to g by 3. 4mg minus tension. So this is a P is equal to 4mg minus 4mg by 3. So this tension is equal to, what is it? 12 minus 4. 12 minus 4. This is 8 mg by 3 is the tension. Tension is 8 mg by 3. So tension is 8 mg by 3. This is the tension. And here, what is the force acting on this spring? Is spring force engine. What is the force acting on this spring? So the force acting on this spring is force acting on spring, that is FSP is equal to 2D, that is 2 into 8 mg by 3. This is 16 mg by 3 is FSP. FSP is equal to this one. So after getting FSP, what is the elongation produced in the spring? The elongation produced in the spring is here. Elongation, therefore, elongation produced in the spring So the elongation produced in the spring is x is equal to Fsp by k. K means this is the spring constant. K is the spring constant. So this is x is equal to 16 mg by 3k is the elongation produced in the spring. A spring will produce an elongation. So what is that? 16 mg by 3k. This is. So listen carefully here. This is one spring, and here two blocks of masses 2m and 4m are connected by a pulley. So just they are asking that the elongation produced in the spring. For finding the elongation produced in the spring is just replaced by the string. And now it is very easy to solve the problem. Just the spring is replaced by the string. So if the spring is replaced by the string, so this is a 4mg and it is the tension. This is a 2mg, it is the tension because the same string is there, same string. And here, what are the force acting on the pulley and tail? This is a P and it is a T, it is a 2D. So you know how to find out the acceleration of the system. Net to pulling force by total mass. So from that, I find the acceleration G by 3. And any one body. So any block you consider any block and take the free body diagram for that block. So if I consider that 4m block, so free body diagram for that block, So according to free body diagram, I find that the tension is equal to 8 mg by 3. So now the force acting on the pulley. Force acting on this pulley is nothing but force acting on that spring. That is the spring force. So the force acting on the spring, that is the spring force, is equal to 2D. So 2 into 8 mg by 3, that is 16 mg by 3. So the elongation in the spring is x is equal to 16 mg by 3k. That is the elongation in the spring. Right? Right now. Completed. Completed. Yes. So next. See. So next problem. So this is the spring, and here there is a block of mass m is there, and here there is a string block of mass 2m is there. Block of mass 2m. Equilibrium. Equilibrium. So equilibrium means here what are the forces acting? Just listen. Equilibrium and take along. So equilibrium ఇక్కడ రాస్తాను. డ్రా చేస్తాను. Equilibrium. This is the spring, and here a block of mass m. This is 2m. So equilibrium means what are the forces acting? See, first ఇక్కడ చూడు. So this is an equilibrium. The weight is acting downwards. 2mg. And here there is a tension. ఇంకేమైనా ఫోర్సెస్ ఉన్నాయంటే ఏం లేవు. దీని మీద యాక్ట్ అయ్యేది. ఇది ఈక్విలిబ్రియం లో ఉందంటే టెన్షన్ ఈజ్ మస్ట్ బి ఈక్వల్ టు 2mg. అవ్వాలిగా. ఈక్విలిబ్రియం లో ఉంది అంటే టెన్షన్ ఈజ్ ఈక్వల్ టు వెయిట్. Tension is equal to weight. Tension is must be equal to 2mg. Okay. So tension is equal to 2mg. And see, this block is in equilibrium. So the weight is acting downwards. mg. And you know, for this block, tension is this direction. T, and T is equal to how much? 2 mg. So now this is an equilibrium. It actually got the mg act అవుతుంది, tension act అవుతుంది, ఇది equilibrium లో ఉండాలి అంటే. So ఇక్కడ act అయ్యే force ఏంటి? Spring force. So that spring force is must be equal to mg plus tension. Then only it is in equilibrium. Then only it is in equilibrium. So this spring force is equal to mg plus tension is 2 mg. So this is 3 mg. Spring force is 3 mg. This is actual. So equilibrium lo unte ikkada 2 mg, the tension 2 mg, and ee block meeda the weight mg, and here the tension is 2 mg. And what is the force acting on that spring? Spring may act a force mg plus t, that is mg plus 2 mg, that is 3 mg. Now the question is, if the string is cut, if the string is cut, is string cut cheste, if the string is cut, then accelerations of blocks just after cutting the string, and a long time ago, just after cutting the string. But string ni cut చేసినప్పుడు what is the acceleration? If the string is cut like this, string is cut like this, string ni cut చేసాం. If the string is cut, if the string is cut like this, cut చేసాం. So cut cheste, what is the acceleration of these blocks? Acceleration of the blocks. So whenever the string is cut, eppudithe string cut ayipotundo, tension in the string is equal to 0. Undadu kada, thought undadu kada. String eppudithe cut chesamo, tension in the string is equal to 0. Idi concept. String cut ayinappudu, after cutting, tension is equal to 0. So tension is equal to 0. Now, if you consider this one, block of mass m is there. This is the block of mass m. And here, asal din med act a forces chodam. This block med act a forces. So what are the forces acting? Spring force is up like this. Idu untadi. This spring force untadi. Spring force is equal to 3 mg, and here the weight is acting mg. Mg is there, but the tension is equal to 0. Tension 0. There is no tension. After cutting, tension is equal to 0. So this is 3 mg, this is mg. No doubt this block is going up with the acceleration a1. A1 and acceleration there. So what is the acceleration of that block? ma1 is equal to 3 mg minus mg. So this is ma1 is equal to 2 mg. So a1 is equal to 2. This is the acceleration of the first block, or block acceleration. So now, if I consider that second block is considered. This is a clear. See that tension is upward. What are the forces? Tension actually is equal to 0 if the string is cut. So only force is acting. What is it? 2 mg is down. So with the acceleration a2, So this is a 2ma2 is equal to 2mg. So 2m is cancelled. A2 is equal to g. Acceleration of this block is equal to c. అంటే ఎప్పుడైతే స్ట్రింగ్ ని కట్ చేసావో just after the string is cut here, just after the string is cut, ఇప్పుడు this block is going up with an acceleration 2z, with an acceleration 2z, and this is actually ఇప్పుడు నేను ఇది చేయాల్సిన అవసరం కూడా ఎందుకంటే ఇది కట్ చేస్తే this behaves like a freely falling body కి acceleration ఇచ్చి, so just it is cut, it is behaves like a freely falling body acceleration is g. Okay, so a2 is equal to g, that is a1 is equal to 2g, a2 is equal to g. These are the acceleration of the system. Acceleration of the first block, acceleration of the second block after the string is cut. Okay. Yes, completed. Completed. So the next one. So next problem. Here it is a spring. This is the block. Another block. So one more block is there. So this is block A, block B, block C. Block A, block B, block C. So what is that? This is a M. This is a 2M. It is M. So the question is, after the system attains equilibrium, after the system attains equilibrium, if the string is cut, string is cut. Find acceleration of the A, acceleration of B, acceleration of the C, just after string is cut. Just after string is cut. So you find that the acceleration of A, B, C just after string is cut. So this block is A and this block is B, this block is C. So first equilibrium. See the equilibrium condition. This is the spring. Here there is a block of mass M. There is a string. 2m. M like this. So ఇప్పుడు ఈక్విలిబ్రియం అంటే ఇక్కడ నుంచి వద్దాం కింద నుంచి ఈక్విలిబ్రియం. So what are the forces? The weight is acting mg. So here there is a spring force FSP is equal to mg. On this spring, the spring force is mg under equilibrium. No force is acting here. Inka vere force, no other force is acting. So just mg and there is a spring force under equilibrium. And for this, what is it? 2mg. And this spring force is acting like this. FSP is equal to mg. They like tension, tension, tension can they calculate that? Alane, spring force, spring force direction. So now here there is a tension. So under equilibrium, 2mg plus mg, 3mg. And see, there is the weight is acting downwards like this. This is mg. And also here there is a tension. P is equal to 3mg. And under equilibrium, what is the force acting on this spring? FSP is equal to 4mg. FSP is equal to 4mg. So this is a equilibrium state. Equilibrium state, the forces like that. Ipudu string is cut. This string is cut like this. The string is cut. See, once the string is cut, it is cut. Once the string is cut, the tension in the string becomes zero. String is cut, so tension becomes zero. Tension, string low tension zero. So once the string is cut, the tension becomes zero. Tension becomes zero. So tension becomes zero. Now here, there is, here this block of mass M, block A, C. This is a C and it is B. This is here. So block C of mass M is there. Here on this spring there is a force. What is the force? FSP is equal to 4 mg. And in this direction there is a mg only, no tension. Tension 0. Tension is not equal to 3 mg. Tension is equal to 0. So this is a 4 mg, this is mg, and body is going up with an acceleration. What is that? AC. Going up with an acceleration AC. So now here there is a MAC is equal to 4 mg minus mg. So this MAC is equal to 3 mg. So acceleration of the block C is equal to 3g. This is the acceleration of the block C. Acceleration of the block C is equal to that one. So now, acceleration of block 2, block B. So this is the B block. Block B is there. It is a 2m. This is B. And see, there is a tension. In this, tension is equal to 0. So what are acting with downward force on this? So the downward force is acting here. What is that? 2 mg is acting plus Fs is equal to mg is acting. So this block is moving with an acceleration a bit down. So what is it? MAB is equal to 2 mg plus mg. So this is MAB is equal to 3 mg. So 3 mg. MAB. This is 2 MAB. 2 MAB is equal to 3 mg by 2. So this is AB is equal to 3g by 2. This is the acceleration, and it is a downward, and this acceleration, it is upward. That is upward. So now we'll come to that block A. Block A. So this is a block A. Block A of mass M here. So what are the forces acting on this one? The force acting on this one is this is, what is it? mg. Okay. So that is mg. And here, this is mg is down here. This mg is down. So the net force is equal to 0. Acceleration of block A is equal to 0. This is the acceleration. So the net force is 0 here. Acceleration of block A is equal to 0. Okay. So what is that? The acceleration of block A is equal to 0. Acceleration of block B is equal to 3c by 2. Acceleration of block C is equal to 3c. The string is cut. Completed, huh? Completed. Yes. Okay. Next question. Butcher. So after the system is equilibrium, if the spring is cut, spring ఎక్కడ spring ని cut చేసి, so this spring is cut, like this. This spring is cut. After the system is in equilibrium, if that spring is cut, so after equilibrium, so what is the acceleration of this one? Acceleration. So first it is in equilibrium. So that is in equilibrium. Hello? Bye. There is the string M is there. This is 2M. This is M. So under equilibrium, mg is there. Look at spring force. What is the spring force? Mg. And here this is 2mg. And here the spring force is Fsp is equal to mg. Fsp is equal to mg. So now here this is, what is that? Tension is equal to 3mg. Tension is equal to 3mg. And this one, see, it is cut like this. You could cut chase it. So this is what is that? Mg. Okay. So that is mg. And now here the tension is there, 3mg, and this is a spring force is equal to 4mg. Okay, spring force is equal to 4mg. So the spring force is equal to 4mg. Now see, what is that? If the spring is cut here, ఇక్కడ కట్ చేస్తే if the spring is cut here, cut cheste. So this is a block A, block B, block C. Block A, block B, block C. So it is a cut. ఎప్పుడైతే ఇక్కడ కట్ చేస్తారో ఇక్కడ కట్ చేసినప్పుడు what is that, after cutting the spring force is equal to 0 after cutting. After cutting, spring force is equal to 0. So after cutting, spring force is equal to 0. Spring force is equal to 0. Here there is, this is the block of mass M. Here there is a string. Two M is there like this. So this is a 2M. So this is C and it is B like this. C and B. C and B is connected by same string. C and B connected by same string like this. So the weight is this one weight is mg. There is a tension, and here there is a tension, and this weight is what is it? 2mg is acting like this. Okay, 2mg, and also the spring force is there. The spring force is mg is acting. This is FSB is equal to mg is acting. So this is, these two bodies are connected by one string. The two bodies are connected by one string. So note here, if two bodies are connected by one string, then acceleration of two blocks are same. Acceleration of two blocks are same. So two blocks are connected by same string, then the acceleration of the two blocks are same. Acceleration of the two blocks are same. And ఇప్పుడు ఈ రెండిటికి, this is acceleration A and this is also acceleration A. It is coming down like this, coming down. Suppose if you consider this one, ఈ diagram తీసుకుంటే mass M is considered. So this is the mass M is considered, and what is it? So this is a downward, mg is there, and the tension is a downward. Okay, mg is a downward and the tension is a downward. Mg is a downward and the tension is a downward. So mg downward and the tension downward. So what is that? mg minus it is tension is there here. Tension on this block mg. Mg is there, and there is a tension. Tension is acting like this. Yeah, first this one. So 2mg తీసుకుంటే, this is a 3mg. Tension is there. Okay. So this is, what is it? It is coming down with an acceleration gain. This is 3mg minus t is equal to 2ma. 3mg minus t is equal to 2m. Suppose this block is considered of mass m. This is mg. Okay, mg, and here tension is there, and it is coming down with an acceleration gain. So mg plus T is equal to MA. So this one is cancelled. Cancel again. Adjacent. So this is equal to 4 mg is equal to 3 MA. A is equal to this is 4g by 3 acceleration. So acceleration is equal to 4g by 3. So means these two blocks are moved with the same acceleration. Once the string is cut here, the two blocks are moved with the same acceleration. So what is the acceleration? 4g by 3. 4g by 3. Same acceleration, that is the 4g by 3. Okay. Right? So what is the acceleration of this block A? Acceleration of this block A is, see, this is M, and here the force is mg, and this force also mg. So the acceleration of block A is equal to 0. This is the acceleration of block A. So acceleration of the block A is equal to 0, but these two blocks are moved with the same acceleration. Just after the string is cut, just after the string is cut, just after the string is cut. So just after the string is cut, so what is the acceleration? Acceleration is equal to that. Okay. If the two bodies, note, if two bodies are connected by one string, two bodies are connected by one string, the acceleration of two blocks are same. See, suppose here there is a spring constant K is cut into pieces. Suppose this is there, it is a spring. Of a spring constant K, and its length is L like this. Length is L. In general, the spring constant is inversely proportional to length. The spring constant is inversely proportional to length. Spring constant is inversely proportional to length means K into L is a constant. K into L is constant. Now this spring is cut into, suppose, two parts. The spring is cut into two parts. So this length of this spring is L1, and up to this the spring constant is K1 for this spring. For this part, the spring constant is K1. And here, this is L2, this length, and the spring constant of this part is K2. Spring constant of this part is K2. 11. So now we can write that here. This is one part, this is one part. And KL is a constant. KL is constant means what? What is the meaning of KL is constant? So KL is constant means K1 L1 is equal to K2 L2. That is KL. K1 L1 is equal to K2 L. That is equal to KL also. KL is constant. Here L is equal to what is that? L is equal to L1 plus L2. So means K1 L1 is equal to K2 L2. That is K into L1 plus L2. K into L1 plus L2. So now I want to find out that the spring constant of the first part. The spring constant, for getting the spring constant of the first part, if you consider this one, you don't need to consider cheste. K1 L1 is equal to K into L1 plus L2. K1 is equal to K into L1 plus L2 by L1. This is the spring constant of the first part. Spring constant of the first part. Suppose if you equate these two, you don't need to equate cheste. If you equate these two, you don't need to equate cheste. So what is that? K2 L2 is equal to K into L1 plus L2. So K2 is equal to K into L1 plus L2 by L2. This is the spring constant of the second part. Spring constant of the second part. Suppose here the two springs are like this. Suppose here, if L1 is equal to L2 is equal to L. If L1 is equal to L2, and equal ga cut chestare. So spring is cut into two equal parts. Two equal parts. That is, a spring is cut into. Spring is cut into two equal parts. The spring is cut into two equal parts. If the spring is cut into two equal parts, what is the spring constant of each part? And K1 is equal to K into 2L by L. So this is K1 is equal to 2K, and K2 is equal to K into 2L by L. So that is K2 is equal to 3K. So K1 is equal to K and K2 is equal to. And then a spring of spring constant, sorry, okay. A spring of spring constant K is cut into two equal parts. Two equal parts can cut cheste. So until this is the spring. Spring is there. The spring constant is K. It is cut into two equal parts like this. This is one part, and this is another part like this. So this is 2K, and it is also 2K. K1 is equal to 2K, and K2 is equal to 2. Suppose if it is cut into three equal parts, three equal parts. So this is 3K, 3K, 3K like this. So it is cut into n equal parts. N equal parts cut cheste. N equal parts. N equal parts. This is NK, 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 NK. So these are equal parts. ఈక్వల్ పార్ట్స్ గా కట్ చేస్తాం. సో 2 ఈక్వల్ పార్ట్స్ అయితే దిస్ ఈస్ ఫర్ 2 ఈక్వల్ పార్ట్స్. This is for equal parts for n equal parts. For n equal parts, the spring is cut like this. That is the spring constant. Is completed. And see, there is a combination of these springs. Combination of these springs, there is series combination. Series combination. See, the springs are connected in series. This is the spring of a spring constant K1. Another spring of a spring constant K2 are connected in series. And a load of mass here is attached here. Load of mass M is attached here. Now, what is the effective spring constant when this combination is called series combination? The combination is series combination. So what is the effective spring constant of the combination? Once it is suspended here, some elongation is produced in the combination. Elongation produced. So this elongation is X. And ikkada deentlo kuda elongation produce avutundi, that is x1. Deentlo elongation produce avutundi, that is x2. The total elongation here, total elongation x is equal to x1 plus x2. Total elongation x is equal to x1 plus x2. You know here x is equal to spring force by, what is that? K. Spring force by K, that is. So this is the spring force FSP by K, K effective. And ఇక్కడ చూడండి, ఈ బ్లాక్ ఇక్కడ పెట్టినప్పుడు దీనికి సేమ్ ఫోర్స్, దీనికి సేమ్ ఫోర్స్ యాక్టివ్. సిరీస్ కాంబినేషన్ కదా. So this is FSP by K1 plus FSP by K2 by this. So these are cancelled. So now 1 by K effective is equal to 1 by K1 plus 1 by K2. So this is the effective spring constant when the two springs are connected in series. And then now, so this is K effective is equal to K1 K2 by K1 plus K2 రాసుకోవచ్చు LCM కట్టి K1 K2 by K1 plus K2. This is in the series combination. Suppose the springs are connected in parallel. Parallel combination. So parallel combination means here, this is the parallel combination. It is one spring of spring constant K1, and this is the another spring of spring constant K2. A block of mass M is there. Block of mass M is connected like this. Connected. And see here, there are different springs connected by the block of mass M. Here there is a spring force FSP1, and here there is a spring force FSP2. So this is mg. Mg is nothing but what is that net spring force. Net spring force. Okay. So this is elongation is the same. Series parallel combination. Parallel combination. ఒకవేళ ఈ బ్లాక్ కిందకి ఇలా వస్తే సో దీంట్లో ఎంత elongation ఉంటుందో దీంట్లో కూడా అంతే elongation ఉంటుంది. దీంట్లో ఎంత elongation ఉంటుందో ఫస్ట్ బ్లాక్ లో అంటే ఫస్ట్ స్ప్రింగ్ లో ఎంత elongation ఉంటుందో దీంట్లో కూడా అంత elongation ఉంటుంది. So this elongation x is the same. X is same. అంటే ఇక్కడ చూడు ఇక్కడ ఏంటి స్ప్రింగ్ ఫోర్స్ FSP is the same. For both the springs FSP is the same. Here x is the same. మరి x సేమ్ గా ఉంటే ఇక్కడ నేనేం రాయొచ్చు here FSP net is equal to FSP1 plus FSP2 net spring force. Net spring force acting on that is equal to that. But spring force under what is it? K into x. So this is a K effective into x. This is equal to K1x plus K2x because x is the same here. X is same ground. So this x is cancelled. So K effective is equal to K1 plus K. This is the effective spring constant when they are in parallel combination. Parallel combination lo effective spring constant. Okay. Parallel combination effective spring constant. That is effective spring constant in the parallel.